Hi class, welcome to today's online lesson called Complex Numbers, where worlds collide. And today, what we're going to do here is we're going to merge together two very important number systems that exist. One is the real number system, which you should be familiar with. The real number system is the number system that you've been working with ever since you started your career in school, with numbers, normal numbers like 1, 3, 18. Just plain old counting numbers that we learned a long time ago. We added some numbers to that system. They may be a little bit different. They're called irrational numbers. They exist as well, like pi and the square root of 2. Those are all irrational numbers that we don't necessarily use in this lesson, so I'm going to leave them out. For the purpose of today's lesson, let's stick with numbers such as just whole numbers, 1, 3, 18. You could also have numbers like 1.5, 1/2, fractions, and decimals. Really, any numbers that you've been used to for your entire life. When we look at the other world that's going to collide today, it's the imaginary number system. And the imaginary number system, we just sort of scratched the surface today in class. And it's all based on the unit I, and I standing for the square root of -1. With that imaginary number system, we can now find the square root of something like -4. Since the square root of 4 is 2, and the square root of -1 is I, we'll call the square root of -4 2i. The square root of -36, for example. Since the square root of 36 is 6, and the square root of -1 is I, you would call the square root of -36 6i. So what I mean by worlds colliding, we can actually take numbers from the imaginary system and numbers from the real number system and add them together to make what's called a complex number. So complex numbers really make up this system. Complex numbers are really made by the two systems coming together. For example, take the number 3, the real number 3 that we have here, and the real number 6i that we have over here. Well, if you take those two pieces of the puzzle together, 3 and 6i, and you link them with any symbol like a plus sign or a minus sign, you get what's called a complex number. 3 plus 6i is a complex number. And that complex number, a number like that, can be the solution to a quadratic equation that we formerly thought had no solution. Complex numbers are used in applications, and I have some examples of those. I found a pretty cool website called Pico Monster, and I'll put the link to that on the wiki. But if you have any interest in seeing other examples of where complex numbers are used, check out that link. It kind of looked like a pretty cool site. I was playing around with it a little bit, and if you want to take a look at that and we can talk about it on the side, let me know. But let's go ahead and focus on what this complex number system and how it works. And the way that you're going to explore this is by adding, subtracting, multiplying, and dividing complex numbers. And you're going to investigate how you might do that. For example, if you take the complex number 3 plus 6i, and you want to add to it another complex number like 2 minus 5i. These are both complex numbers. Adding them is really simple. All you do is add up their real parts, 3 plus 2. Since we're adding, you just add them together to make 5. And then you add their imaginary parts. And that works just like any normal variable terms. You would take 6x plus -5x would be positive 1x. Well, 6i plus -5i is positive 1i. So I showed you how to add two complex numbers. If you were subtracting, you would just subtract the real parts and subtract the imaginary parts. With multiplying and dividing, it gets a little trickier because there are certain tricks involved. So there are certain tricks involved. And to do that, I'd like you to go ahead with the investigation and follow some of the instructions that you see. Adding and subtracting part 1 that we see in this investigation. Pretty basic. Go ahead and complete part 1 on your own. You can go ahead and print this investigation handout from the link on the wiki on your own, and we'll check those answers tomorrow as a group. Then we'll get to do some homework in class. Part 2, multiplication. The one thing that you want to watch out for, you're going to treat these the same way that you would foiling. For example, in part 2, letter A, they want you to take 2 minus 4i times 3 plus 5i. And we're going to FOIL. You're going to do first, outer, inner, last, and see what you get. You should end up with a trinomial, but that trinomial can be simplified. Here's what I mean by that. I'm going to switch the ink here to blue and show you that the 2 times 3 is just 6. No worries there. Then I'm going to do the inside and the outside here in green. The outside would form 10i, 5i times 2, and the inside would form negative 4i times 3. That's negative 12i. Let's go ahead and combine those before we write it in the next step. So negative 12i and positive 10i would combine to negative 2i. Finally, in the last step, let's do that in black, we're going to have negative 4i times positive 5i. If those were x's, and it was negative 4x times 5x, we would get negative 20x squared. Well, here, since it's an I, we end up with negative 20. I times I is I squared. So I want you to think about what the next step might be. Think about what we did in class today regarding the I cycle and what I squared is. What is I squared by definition? And if you have that negative 20 times what I squared represents, think about how you could combine the black part with the blue part to make a real number. Hint, anytime I squared is involved, that's going to become part of the real portion of the solution here. So negative 20 I squared should not be part of your final answer to part 2, letter A. You shouldn't have any squareds involved in B, C, or D when you're multiplying. Now, conjugates. I'd like you to work through complex conjugates and see what happens, generalize what happens in part 3 here. When you multiply something by its conjugate. The conjugates are C and C and D. See what happens especially with those when you end up multiplying. Because those conjugates are going to come into play in part 4. And I tell you what, let's make a deal. Part 4 would be very difficult for you to do on your own. Go ahead and give it a shot, see if you can do it. But if you have any difficulty with part 4, don't sweat it. That's probably where we'll start the major portion of the lesson tomorrow, talking about division of 2 complex numbers. They do involve the complex conjugate, but it's rather involved. So that's something I'd like to guide you through when we're all present in the classroom tomorrow. So your homework tonight would be to complete parts 1, 2, and 3 as best you can, and come to class prepared with questions. Post any questions to the discussion tab at the top of this page, or just let me know if you have any questions.